the differentiation, and you also have the supposed line. Now, please, you actually must have one more line. That means x equal to something. So I need to be very clear first. I think in this case, it's x equals to 2, right? Okay, show me x equals to 2. Very good. So the 0, where do you get x minus 2? Now I'm very clear. But where do you get y minus 0 then?
Because the y coordinate is 0.
Okay, be very careful here. So make your line disappear first. Not cancel, yeah, disappear. No, not that line. The tangent line. Very good. Ines, can you hear us?
Yeah.
Good. Right. I'm explaining to Kyoko. I'm going to pause for 1 minute and I'm going to resume. We're just waiting for you. Please be quick and set up everything. If you're not ready by 1 minute, just watch Kyoko's video so you can follow. Yeah. Kyoko, please wait forward. Yeah. This is so that I don't have to repeat. Ya, masuk. Oh, here. Oh, there. Oh, you're smarter than me. All right, very good. Okay, let me put on my so. Anish, I hope you have your Desmos ready also. We'll pay attention to Kyoko's video first, right? So please check, Anish, whether you have the original graph, the differentiated graph, the line graph, right? You have everything there? Let me check. Yes. I'm referring to the homework I assigned you, Anish. So not this kind of graph, but the graph of sine x plus cosine x. Have you done that already? Right. Sorry ya sayang ya, jadi aku bisa. Now, Kyoko, while waiting, why don't you fix the coordinate first? So you're wrong in using 2, 0, but why? Make the differentiation graph disappear. Yeah, and then look at the intersection between x equals 2 and the original graph. Click on that. What does that say? 2 comma minus 0, 3, 7, 8. That should be the point that you're using. Does this make sense first? I don't want you to memorize this.
No.
All right. Now, when we say x equals to 2, we are choosing a random x, right? Oh, I just want it to be 2. That's totally fine. But it means that on the original graph, the point is fixed for us. Is 2 comma minus 0, 3, 7, 8. It's not 2 comma 0 by any means. Do you understand what I'm saying first?
Okay.
By choosing x equals to 2, you have chosen 2 comma minus 0.878. Okay. And in algebra, you will see that that's how we start. Right? They will choose a random point for us. Let's say x equals to 5. So we will have the y immediately by substitute. Ainesh, move a bit to the right and move up so I can see your decimals. Right? Very good. Right? Very good. Most excellent. Now, you're following Kyoko's one. So far, so good. Before we, Ainesh, you can zoom in. How can you zoom in? That's very nice and wonderful.
I got my dad's phone there.
Ah, your dad has come back. All right, my hi to him. Yeah? Now, before both of you continue, I should be teaching you this one thing that in Desmos, you can save your working. We'll be using Desmos for around 3 things. So this is important. To do that, you must first sign up. How do you sign up? You just sign up using your Gmail. That's all. So please sign up first so that later we can save our graph.
You probably have an account already.
Or probably, yeah, I think you can also use that account as long as you remember. Use whatever account you are. Yes, wonderful. Now, in this untitled graph, please save it as an appropriate title, which is the proof of product rule. Please save that as that title. Yoko, are you okay with signing up proof of product? Right. Now, make the original graph appear, Ainesh, and make the x equals to 2 also appear, please. Wonderful. Yeah, correct. Yes, correct. And then I think you have to zoom in or zoom out a little bit to make the graph show. Find the graph. Okay, I think you have to zoom in there. So shift it, yeah, and make it bigger, much bigger. Very good. Right. Very good. Okay. Very good. Yeah. Okay, even bigger, even bigger. Let's focus on the point, the point that we're interested in. Use your hand to zoom in, your 2 fingers to zoom in. Right, very good. Even more so, even more so. If not, it will give you difficulty. Okay, around there. Now, I just asked Kyoko to change something because I was correcting her mistake, right? Ainesh, do you see what mistake happened originally? If you don't, I'll give you a hint, yeah?
I don't.
Now, click on the intersection between x equals to 2 and the original graph.
Sorry, what do you say?
Finger, click the intersection between x equals to 2 and the original graph. Use your finger. Your pen also. But a finger will be more helpful here. Very good. Click on that. Now that reads as a point, a certain point. At this point, Kyoko has randomly choose x equals to 2. So that is the point that we are interested in. Is this point very important or just a random point?
It's important.
Then do you see the mistake originally done on the tangent line? The tangent line. No. Now both of you turn on your tangent line. Right. Ainesh, turn on your tangent. Okay, right. Now look at Kyoko. Kyoko has fixed her mistake. Her tangent line is now intersecting the important point, correct?
Wait, so this would be y
Yeah,
0 point, so y plus 0.37.
correct. I was hoping that you could see it before I tell you. Right? Okay, so please do that. Kyoko, are you okay with this? You understand that that is important to correct.
Mm.
All right. Now, why don't you turn on the first of all, why don't you add the word m in front of your x equals to 2? Remember, you can add the word m in not there in your tangent line. Yeah, you add the word m there, m, and then you add the slider, right? And then you can now adjust your m more freely. Okay, Ainesh, I see that you have also corrected the mistake. Now, add m in front of the on the tangent line, not 0.4472, please, but we be more flexible. We replace that with the letter m. Please do so, Ainesh. Yeah, so erase all that and replace with the letter m and do a slider. Okay, around there. So that's your prediction, right? Yeah, that's good. Now, Kyoko, also save your graph first. The title is Proof of Product Rule, right? Now, Ainesh, to confirm, you may want to play with the M to make a better prediction, right, of the tangent line, right? Play with the M until you get a better prediction. Right, make it into a tangent line, a glancing line. That's not glancing. Yep. Go on, continue. That's not glancing. That's not glancing. Yeah, not yet. Visually, what does a glancing line look like? That's not glancing. That's not glancing. That's cutting. Yeah. That's still cutting. Yeah, you should play around there. That's not glancing. That's not glancing. I know that's cutting at one point, but that's cutting. That doesn't feel like glancing. If you want a visual sense of what is glancing, it's important. Look at Kyoko's glancing line. Kyoko's line does seem to be glancing instead of cutting. Look at Kyoko's graph. You must have a visual sense of it.
Minus 0.6.
Yeah, but I want you to see it visually, not the number, right? Not just the
Oh,
number.
is this glancing?
That's cutting through. Look, I'm not saying words here. It really visually feels that the line is cutting through. You want a line which glances. Now, this is almost glancing, almost. Yeah, be gentle with your shift. Be gentle with your shift. Yeah, around there. This is still cutting, but almost glancing. Do you have a visual sense of it? Yeah, this feels like glancing. You understand? This is now cutting again, right? Then that's glancing again.
I see.
Do you understand the visual feel of it? Okay, yeah, clear, yeah? Glancing and cutting are something that we should have a sense of, visual sense of, right? If not, they're just numbers and it doesn't make sense. In your case, yours are minus 0.7 and Kyoko is minus 0.6. I mean, how can I blame both of you? Visually, it is not the most accurate thing, but it is close enough. So both your answer might be correct, right? Now, what is the purpose of doing all this time-consuming thing, Kyoko? Why are we doing this?
To see the find the gradient of the tangent.
Yeah, but no, that's true. That's true. But why are we doing this?
To prove the
product rule is the product rule is correct or not?
Yeah.
Am I bluffing you or not? Remember it, right? Unless you want tuition to be a repeat of class, if that's what you want, this is a total waste of your time. It's a very precious time that we have on you. If you want the proof, though, tell me, Ainesh, have we proven the product rule? Have we?
I think so.
No, we have not. We haven't tested the differentiation graph. We have not. In fact, the differentiation result, which one's the differentiation result? Tell me.
This one.
Yeah, I mean, it is in your case, it is invisible. So I guess we should use that. Kyoko, make yours visible and tell me how do we use this differentiation graph? The differentiation graph is supposed to tell us something, right? How do we use it? click on the point that we're supposed to use, both of you. If you find this very confusing, make everything else invisible. I want you to make the original graph invisible. I want you to make the tangent line invisible. So there are only two things here. The differentiation graph, and now that is the point. Now, Kyoko, I want to see you click the point. Both of you did not click this point at first, perhaps because it is very confusing. Now it is clear. Look at the result of this point, 2, not surprising, comma, minus 0.6536. What does this tell us? Kyoko? What does this tell us?
This is the gradient of the tangent
line, which is close enough or not to your own prediction.
Yes.
How about you, Ainesh?
Yeah, okay, that makes sense.
So this is a rather rough proof of the product rule. The product rule seems to make some sense because of this. Do you guys understand?
Yeah.
Right? The product rule does not seem to be bluffing, but you cannot be too sure because visual confirmation are not the most accurate thing. I mean, I cannot ask you to go 0.6536 in your visual confirmation. I can't, right? Okay. Now, if product rule seems reasonable, let's go back to save this thing first. Just save everything first. Just press the button save, right? Save. Right. Save. Right. Now let's go back to the Jamboard and let's use product rule. Right. You'll be writing on the Jamboard. You have to get used to the product rule because it ends up being used a lot, like super a lot, right? Even though it doesn't seem to make a lot of sense. At least it seems to be correct. Now, I told you product rule is used when it is something times something. Quotient rule when this over that, and chain rule when this over that. I'm going to give you 3 scenarios. You tell me which one should we use product rule with, right? 3 scenarios. 1, 2, 3, right? Okay. Okay. Kyoko, which one should we consider product rule for? Ainesh, you should be doing your thinking.
Oh, can I see?
Kyoko, would you mind giving it to Ainesh, the first guess?
Yeah.
Ainesh, please make your guess.
1 and 2, I'm guessing.
1 and 2. So I'm going to write that down first, right? PR, right? Okay. So we'll say that this is PR and PR. Now, we shouldn't stop here. We should just learn everything, right? Which one for quotient rule, which one for chain rule. So you guys must have some opinions on this first, right? Okay, which one on quotient rule and which one on chain rule? Kyoko and Ainesh, you write your opinions, right? Okay. Just for your information, it is possible to apply more than one rule in certain situation. Okay. So it is possible for a situation to use more than one rule. It is possible. They will give you the same answer or the correct answer, right?
Oh, what color am I?
Up to you. Just make it different.
Okay.
Right. So Kyoko and Ainesh, which rule for which scenario, right? Is that you, Ainesh?
Yeah, I'm blue.
All right. Right. So Ainesh, you're saying that scenario 2 is product rule and quotient rule. That's what you're saying.
I'm assuming, yeah.
All right. Let's see where that leads us. Now, Kyoko, write something else. Huh? You can write your own opinion, right? Right. At least I should assure you that all rules can be applied in at least one scenario. All rules can be applied in at least one scenario. So you will have no, You have no orphans here. Lah. Everybody can be applied at least once, maybe twice, maybe twice. Right? I haven't seen any chain rule, so I'll give a very brief description. Chain rule is when something is inside something else. There's a layer, inside layer, outside layer. It's like an onion. If you see certain layering, then maybe you should consider chain rule, right? There will also be product rules here. So I need to see some product rule guesses, Kyoko. I also need to see some chain rule guesses, Ainesh and Kyoko. I need to see that. Okay? You're venturing into the dark. Please make a guess. Don't take too long. I'm not asking you to be correct here. I'm asking you to venture a guess. Everybody should have at least one rule. Product rule should have one, at least. Quotient rule should have one, at least. Chain rule should have one, at least.
I don't know.
Right. I know you're guessing, but just guess lah. All right. Have you done guessing, Kyoko? How about you, Ainesh?
Yeah, I mean the red guesses are also my guesses. So it's
right. So yeah, let's assume red is Ainesh, right? So I will say which one is right and wrong, and I will demonstrate, right? Okay. Very interestingly, you should use PR here. Maybe both of you see already. If you want to use PR here, you will consider it as sine x times sine x. Is this what you think, people?
Yeah.
Then you are correct. It is also very interesting to note that you can use chain rule here. You will see it as sine x layer square.
Yeah.
Right? And that's the reason why we can use chain rule. Do you know what a chain rule is? You don't know, but you are seeing it applied well. Very good, right? You understand, Kyoko? Let's see how we use it later on, right? Now, how about question 2? Question 2, quotient rule and quotient rule. I mean, this is obvious, right? Quotient rule is for division. Very interestingly, though, you can also see it as product rule. How? Please observe. You will see it as sine x times. Why times? Because product rule requires time, right? Times
1
cosine x to the power of minus 1.
Oh, yeah.
Okay, very good. Which necessitates chain rule. Which necessitates chain rule because of the minus 1. But you can use a combination of product and chain rule or simply quotient rule, right? Good guesses for all of you. Now, for scenario number 3, unfortunately, it is not product rule because it is not sine times 2x, and I cannot modify it that way. I cannot. Can you use chain rule? Yes, because this is the inside layer and this is the outside layer. Do you understand what I'm saying, Ainesh and Kyoko? Inside layer, outside layer, chain rule.
Yeah. Oh no. Oh yeah. Okay. Can you also use product rule for question 3?
No, because you cannot see it as sine times 2x. This is very confusing, but it is not true at all.
Because you can change sine 2x into 2 sine x cosine.
If that is what you mean, then I take my word back. You are absolutely correct. You can use identities and later on use product rule. Excellent. If that's what you mean, Ainesh. Very good.
Yeah.
Very good. In fact, this is all valid techniques that we have to know. Okay. All of you have wonderful guesses. It shows that you're thinking. Any questions, Kyoko and Ainesh?
No.
Right. I will show you how to do quotient rule. I will show you how to do chain rule. And this 1, 2, 3 will be what we are doing. We'll be doing scenario 1, product rule and chain rule. We'll be doing scenario 2, product rule and quotient rule. We'll be doing scenario 3, product rule and chain rule. Understand?
Yeah.
Okay, so I'll show you product rule first. No, I'll show you quotient rule first. I'll show you product rule already. This one. I'm not explaining why that is correct. I just prove it to you that is correct. So we cannot do too much in intuition, yeah, right? So I'll just have to pick and choose what I show you. Now, quotient rule. Quotient rule start with U divided by V. I hope that makes sense. And therefore, What is the dy dx? What is the result of the differentiation? The result of differentiation is a bit weird. So u prime v. Ainesh, what is u prime?
U differentiate.
Yeah, u differentiated times v, not differentiated, right? Minus u v prime. Why minus? Why product rule plus? Don't know. I'm sorry. I choose not to explain that. I'm so sorry. Yeah, I'm so sorry. Right. Over v squared. This is a square, right? That's not a prime or whatever. One more time, quotient rule is u prime v minus u v prime over v squared. Why like that one? I can only say that it will be correct. Any questions so far?
No.
Right. For chain rule, I will have to demonstrate a little bit more clearly lah, because chain rule is best demonstrated, right? It's not a formula, so to speak lah. Now, I will give you another case of a chain rule, right? So, sine x squared. People, let's agree first. Sine x squared is a layer. Got inside layer, got outside layer. Do you agree or disagree?
Agree. Agree.
Then who is the inner layer and who is the outer layer?
X and square.
X squared is the inner or the outer?
In
Inner for both are good. The outer is what?
sine.
Sine of x squared. Now, this is how you do chain rule. Observe, observe. You're going to, in your mind, pretend that this is you. Why do I ask you to do that? Because sine x squared is not basic. Sine x is basic. By right, you do not know how to differentiate sine x squared, but you know how to differentiate sine x, because sine x is basic. Do you understand, Ainesh and Kyoko?
Yeah.
So by pretending that it is u, I'm pretending that it is basic because sine u is basic, right? Kyoko, what's the differentiation of sine u? Okay, I'm going to ask it slightly differently. Kyoko, what is the differentiation of sine x?
Cosine x.
Yes, you memorized for me yesterday. We kind of prove it with the Desmos. So, Ainesh, what is the differentiation of sine u?
Cosine u.
You're venturing a guess, and that's correct. Cosine u. However, this is where the chain rule comes in. So the chain rule comes like this. Pretend that the inner layer is u so that you can do a basic differentiation. And then you must address the inner layer now by doing u prime. Why like that one? No explanation given for you in tuition. However, I will guarantee that this is correct under Desmos. What is u prime, Kyoko? What is u prime, Kyoko? U prime is the differentiation of u. What is u? X squared, right? What's u prime?
X minus half.
No. What's the differentiation of x squared? You know this. You know this, Kyoko. What's the differentiation of x squared?
Minus x1.
Try again, try again slowly. I mean, I know differentiation doesn't make sense. Ainesh, help us. What is the differentiation of x squared?
2x.
2x. Do you understand, Kyoko? X power 1, the 2 go down. Is the first pattern you learn. It's a weird but correct pattern. Would that be okay? Yeah. Again, I know that this doesn't make sense. Okay. Yeah, I'm asking you to memorize pattern. That's why I'm not being generous here. I understand that the situation is one of memorizing a lot. Right? So bear with me, bear with it for a while. So the final answer will be that this is cosine x squared times 2x. This is the form of chain rule and how to use it. This is the first time you see it. People, go to your Desmos, save proof of chain rule and show whether this is correct or not. Please do so. Do a new page. You can do a new page, right? So new blank graph. Yeah, correct. And then save it as proof of chain rule, right? Ainesh, if you don't know how to, start a new page, you show me your tablet first.
A new blank graph, right?
Yeah, new blank graph, and then you can share under proof of chain rule. Please prove it to yourself. We'll use our time like this. Right, that is the graph sine x squared, Kyoko, and that's the original graph lah. So good job. What do we do after this?
Oh my god.
Okay,
Why doesn't
Kyoko. The first graph is fine though. I think the second graph, I cannot see your graph. I
Mine.
cannot see your graph. Go to the left. Go to the left. Go to the left. No. I don't think you did anything wrong. No. That's
Then
why
is
we
it so
have to.
weird?
I'm sorry, what?
Why is it so weird?
Oh, well, no, it's beautiful. I mean, you just have never seen it before. It's fine. It's totally fine. Proceed with your normal procedure. Kyoko, why do you have sine 2x? That is not the differentiation of sine x squared. At least that's not what I claim. I claim that you need to use chain rule, and the result of the differentiation is on your Jamboard. It's not sine 2x. Look at your Jamboard. I claim that we need to use chain rule, and the result is there. Standard procedure, Ainesh, yeah? We need the tangent line and we need the x equals to something. We need those 4 things, right? Yoko, are you okay with the result? Did you see the result? Cosine x squared bracket first. You must close the bracket first, Yoko. Close the bracket first, and then no, close the bracket.
How do we know which x to use?
No, you at this point choose any random x you want, really. Yoko, then times 2x. Good.
Is it possible to use x equals to 0? No way.
No, totally possible. It's just that I feel that it will be a very bad habit. It's a very bad habit to use 0 and 1. At the very least, it must be 2 or some strange number. Because minus 1 is okay, but again, I feel that it will be very confusing later on. Not in this simple situation, but there are situations where that's not a good habit. That's why I start off with 2. So 2 is a reasonable choice every time. Please practice a good habit from now. You will see why later 0, 1, and minus 1 is not a good choice. Not now, later. However, it is possible. However. Kyoko, you need 4 things, right? If you forget the 4 things, you save this graph, you go back to the previous proof, right? I need you and Ainesh to have the proving logic in your mind. So save this graph first, Kyoko, proof of chain rule. And then you can go back to the previous proof. Remember what we're doing there. How do you go to the before? Yeah, if you know what to do, then you can do it. Not then you refer. Not product rule. Oh yeah, it is. Okay. Maybe you should say proof. Yeah. Okay.
Did I do this right?
Let me see. Move to the up, move left. Yeah, thank you. Move up, move left. Right. So you have the M set up, you have the X equals to 2, and then so, okay. So let me see your X. So just to confirm, I think you set up your line correctly, right? Your line is not intersecting the important point, right? The point that you choose randomly, right? Now change your M lah, so it is glancing, right? That's the procedure, right?
Yeah.
Right? Make the M glancing. Okay, still cutting, still cutting. Definitely still cutting. So if you cannot make it glance, that means you have to extend the thing, right? Okay. And if you cannot make it glance even after that, I think you should consider negative. In fact, your sense of negative and positive is a little bit lacking right now. You must be able to sense whether the graph is, the line is actually negative or positive gradient immediately. It will make your life easier.
Okay.
Why is your tangent line not cutting the point, Jacob? Your tangent line doesn't seem to be cutting the point, right? Make the differentiation graph disappear, please. It's confusing. Right. Don't you see that your tangent line is not cutting the point? That is not glancing. That is not glancing, Inish. I mean, it's better, but it is close, I would argue, but it is not glancing at all.
Oh.
Be sensitive here. Be a bit sensitive here. Be a bit sensitive. Be a bit slow here. Or use your typing. You're getting worse, I believe. I think you should be going to the other side. I think you should. Yeah. See. A little bit of sensitivity works here. Is this your final guess? You don't have to be so accurate.
I like this.
All right. Now, then again, our purpose is to prove chain rule, right? Am I bluffing you or not? So how do we do that? I would suggest that you make the original graph disappear at this point. It's less confusing that way. And then make the differentiation graph appear, right? That's what you need to do. And then what do you need to look at?
X equals to 2 intersection.
Yeah, so it might be down there or something, right? It might be down there.
Oh.
Right, so Kyoko, you have a reasonably good guess, right? Minus 2.6, right? Our purpose is to prove the differentiation, correct? How do we do that? Make the differentiation appear, make the original graph disappear. It's very confusing. Right, now.
It's minus 2.6.
Yeah, minus 2.615 according, yeah. So your guess is very close one, Inish, don't you think?
Yeah.
Kyoko has a better guess, minus 2.6. But you know what? At this point, did we serve the purpose of proving the chain rule?
Yeah.
Then save yours as proving chain rule, Inish, because it will be good, right? It will be good to refer to Big Bang later. Please save it. So Kyoko and Inish, I hope I have shown you at least chain rule. I'm not bluffing you. And therefore, I think you have to learn how to do chain rule. All right? Okay, Kyoko? I think chain rule is less of a formula. Product rule and quotient rule is more of a formula. But you still need 3 of them. You still need 3 of them, yeah? Just want to say that. Okay, are you ready to apply chain rule, product rule, and quotient rule yourself, Inish and Kyoko?
Yes.
Okay, so go to page 5. I will have created something for you. Okay.
Sorry, can I go to the bathroom?
Yes, please. Right. So page 5, yeah. All right, Inish and Kyoko, please apply your product rule and chain rule. You will need to refer to page 4 to do that. This is product rule, and this is also chain rule. This is quotient rule and also product rule. This can be chain rule. This can also be product rule. So Ainesh and Kyoko, each scenario you will apply 2 rules. No? Please do so. Whenever you have a difficulty applying, please ask them. Ainesh, Jamboard, please.
Yeah.
I'm back.
Yes, Kyoko, page 5. I've already given you the scenarios and the rules to apply. Lah. You will see that each scenario requires 2 rules. You have to test 2 rules for each. It will be a very great demonstration. Right? Right. So a word of advice, if you want to use product rule, set up the guide so that it looks suitable for product rule. For example, scenario 1, you want to apply product rule.
Yeah.
Sine square x is not suitable for product rule. You should rewrite it as sine x times sine x. Then it is very suitable for product rule. Do you understand what I'm saying, Kyoko and Ainesh?
Yeah.
Yeah, you must set it up for yourself. Lah. I mean, the question is not going to do that for you, right? If you forget product rule because it is a memorization, refer to page 4.
Oh yeah, I'm referring to page 4 then, Tato.
Oh, please do. Please do. It's a very good thing to use laptop. Right. Kyoko, set up your product. Don't do sine square x, Kyoko, because sine square x is correct, but it is not helping you do product rule. Understand? Product rule is something times something. So it's better to start from sine x times sine x, right? Okay. Looks reasonable for the first one, Ainesh. Now, please apply chain rule immediately. Lah.
Yeah.
Right. You must set it up for chain rule. How to set up for chain rule? You must set up in a layer fashion. Something inside, something outside.
What is that? I don't know, dude.
Your setup is wonderful, Ainesh, but the way you do chain rule might be incorrect. Lah.
I think it's incorrect.
Right. However, I like the setup. So I am making a big deal of the setup because your setup is great. This answer is correct. This is also one. The setup is correct. Now remember how I teach you chain rule. I teach you that chain rule, you must pretend the inner layer is U. So you're pretending that this is U squared. Why? U squared looks basic. Sine x bracket square is not basic. You must acknowledge that. So Ainesh, you should be differentiating U square in your mind. That's easy to do.
Yeah. Huh? Oh. Okay.
Right. Be careful
sine
of
x is U
your
square.
algebra, Kyoko. Yeah, sorry, Ainesh. Be careful of algebra, Kyoko. You're doing very well, and then your final line is wrong, which is nothing to do with the rule already. You're just messing up your algebra. Be very careful with it. So, Ainesh, I asked you to pretend the inner layer is U, right? So U square, correct?
So the inner layer is U or the inner layer is U square?
No, differentiate U square, right? Differentiate U square.
So
What's the differentiation of U square?
2U.
2U. You write down 2U first. So that's the first part of chain rule. You pretend that it is U square. Then to finish up chain rule, I ask you to times U prime. Still no question asked. I'm so sorry, but that's how you complete a chain rule. Understand?
Sine X.
And then you write down everything. U prime will be cosine, which
Cosine.
conveniently is the exact same thing as the first setup.
Yeah.
This should convince you that at least I'm not bluffing. Right?
Yeah.
Which one's better? Which one's worse? At this point, you learn everything. At this point, you learn everything. So, good one for question 1. Both rules completed. Now, do scenario 2.
I won't have enough space. But yeah.
I'm sorry?
I won't have enough space, I think.
You just move on to the next page. Again, they take half of it. Just copy everything. Okay? You will do that. Kyoko, are you okay? You're looking at the rule, right? No, your second line is correct. That means you apply the rule correctly, Kyoko. That means the final answer also correct already. So this is correct. Okay, so everything is correct so far. This is question 1 for product rule. So now I'm asking you question 1 for chain rule, Kyoko. Set up the chain rule properly. It should be in layer form, inside, outside. Set it up first.
Wait, what? For question 2, right?
Mm-hmm.
The quotient rule.
Yeah.
Is it that complicated?
The formula is complicated, but my first question is, do you need to set up?
No.
Because it's already in the form of division. Yeah. So, but is it that complicated? Well,
so wait,
yes.
the denominator is U by V. Sorry, the numerator is U by V.
No. U by V is the original setup. No, it's the original setup. Something divided by something. The formula is the complicated one. U prime V minus UV prime over V square.
V square.
Over V square. So you only have to apply that. After a while, people just apply quotient rule. I mean, it's just a formula, right? Okay, your setup, Kyoko, this is not appropriate because this square can mean the square of the x or the square of the whole thing. That means it's very confusing, Kyoko. You must set it up in a way that is not ambiguous. Be very clear. The square is square of x or square of sine x. Which one do you think is it? The square of x or the square of sine x? Kyoko. Correct. So set it up like this. The proper writing looks like that. Okay. I think that's more presentation problem. So we should correct it from the start. Right. So you don't write it this way, Ines, for presentation. This one you write y equals 2. Okay. Y equals 2. And then this one is separated. This one is dy dx. Right. That's the result. Okay. They're not equal. They're not equal. Just begin. Right. You're applying the rule well. I would say. Good. Right, Kyoko. So how do you apply chain rule, right? By pretending that the inside is a U, right? The inside is in this case, U square, correct? You must start like this, because you are still starting off. You shouldn't jump immediately to it. Now, what's the differentiation of U square?
2U.
2U, correct? Write down 2U, and then times, to complete times U prime. No explanation given. This is how you complete a chain rule. Understand?
Is this correct?
Just a minute. So in this case, complete your chain rule. Yeah. Let me see. It seems all right. Now, good news. You did the rule correctly. right? There is no need to set up. So good. This is wrong. So it's not the rule problem. You don't have a rule problem. You and Kyoko sometimes have the same problem. It's an algebra problem. It's not okay to have this problem at all. Your mistake is not the rule. You did the rule well.
Oh, sorry. Oops.
That's, yeah, okay. 2u is 2 sine. What is u, Kyoko, in this case? The inside is?
Sine x.
So you should write 2 sine x, not 2 sine. 2 sine x. And then what is u prime? The differentiation of the inside, which is sine x. What's the differentiation of sine x?
Sine x.
Right. Write it down. Conveniently, that is exactly the same as product rule. Right?
Mm.
This should tell you that something is correct. Huh? At least this looks great, right? Right?
Mm.
You're doing it two different ways and they give you the same answer. It should give you some comfort. Okay?
Mm.
And it is true that you're doing it correctly. Right? So you have to do more. Question 2, please. Ainesh, why are you not correcting the mistake?
Sorry?
Why are you not correcting the mistake? Sorry.
I did it, sine square x.
Oh, that's the behind one. And you don't correct the 2 cosine. This doesn't make sense. Come on.
Oh, I thought it was just that because you put the x over there.
All right. Now this is correct. Okay? Now this is correct. As I told you, it's not a rule problem. You have an algebra problem and you have corrected. Now go further. Okay. Now go further. You can go further and simplify more. Do you see how you could simplify even more?
No.
Apply identities. That means look at the list of your identities and tell me whether you spot anything useful.
Wait, can you remove the x? Is it possible to remove the x?
All right. Look at the list of your identities and see what you can do. So Kyoko, instead of flipping back and forth, why don't you write down the formula for quotient rule? I mean, you have to memorize it anyway. They won't give you one. So you must write down u prime v minus u v prime over v squared. Might as well, right? Might as well. You have to write it down every time anyway. Ines, list of identities, tell me. Do you see anything? Do you know what I'm talking about? The list of identities in front of the exam paper. Yeah. Don't you see anything that you can apply here?
I'm looking through.
Kyoko, your application of rule is correct, yeah, but your presentation is a bit wrong. So I'm just correcting them for you. This is the differentiation and this is the origin.
Mm.
So your rule is correct. Your rule is correct. Yes. Yeah, simplify that, please. Right? That's convenient, right?
Yeah.
1 over cosine square x. And now, just for formality's sake, people usually write this down as secant square x, look, if you don't mind.
Oh, no, I don't like that. But okay, yeah, sure.
Right. Okay, so in case your teacher do that, you know that there's a certain, this is more like a preference. Yeah, it's.
Yeah,
take
I
it as
can't write in the
preference.
corner.
Right. So,
I
I mean,
believe-
we're just we're just memorizing stuff here like that. Let's get used.
Yeah.
Right. Okay, so now your first scenario 2 is correct. You need to now apply product rule for scenario 2, obviously at the next page.
Yeah.
Go to the next page and divide it to half.
Oh, I thought, okay.
So, I mean, this is we're doing it together. You're quite looking at the difference because right now your rule is great. You're doing fine, I can tell you, but we can simplify further. Do you see any identities to help you with this? Good. So just for presentation purpose, Kyoko, people usually want to write this as secant square. secant square x. That's preference lah. So please finish it that way. Just take it as it's their preference. Good. Now you did the first rule correctly, quotient rule. Also your first quotient rule. Yeah, congratulations. Now do that with product rule on the next page. I want to see both of you set it up. Ainesh is setting it up properly for product rule. Wonderful. Now dy dx. Ainesh, at this point, I want you to memorize the product rule formula and write down as well. So I want you to write down u prime v plus uv prime. Like that will get the ball rolling. They won't give you, and you need this every time anyway. So please, Ainesh and Kyoko, you set up and then you write down u prime v plus uv prime. Okay, let this guide you, Ainesh, in doing the product rule. And note that I think your v prime will require chain rule. So if you want, you do it separately first. You write down, you follow how I do it. You write down u prime is something. Then you write down v prime is also something.
It's okay, I'll try to write this.
Sure. Okay, good, Kyoko. You're starting to memorize it. So now apply it, please. Then write down dy dx. This is again the proper way. Write down dy dx here. They are not equal, you see. You must write down dy dx. Same thing with you, Kyoko. Oh no, you're fine. No, you're fine.
Oh, not German to be real.
Yeah, dy dx, correct. Dy dx, correct, Ainesh. So you start off as u prime. I think that's correct. Yeah. Okay, I think your u prime v is doing well, Ainesh. Your u prime is correct. Your v is correct. This part is correct. And plus, this is your u. So this is correct also. And then how about your v prime? Be very careful of it. The bracket, please, Kyoko. Yeah, you need the bracket. Just to be clear. So this is a good setup. This is a good setup for product rule because it has time. So now apply your product rule. Good setup. Yes, Ainesh, you're doing v prime separately. That's a wise decision. You should pretend. What is that v? That's not v prime. That's v. This is v.
So it'll be sine x, minus sine x.
Apply your chain rule properly, please.
I'm so confused.
Just write down your v. Just don't change anything. Right? Your chain rule is very difficult to get used to until one day it comes.
Yeah, so this will be cosine x, right? The v prime would be. Oh, okay. I see.
First, you start by pretending the guy inside is, in this case, W lah. You cannot use the letter U, right? Because you already use it. So you pretend that the guy inside is W. Okay. Right. So this is U prime V, which is correct. And this is U, which is correct. And your V prime is incorrect, right? Your V prime is incorrect. Your chain rule is not applied here. You have to apply chain rule here. First thing first, you have to realize that you have to apply chain rule. There's a layer there. Your V prime is wrong. Clear your V prime separately first. Your V is cosine x minus 1. That's your V. So what is your V prime? You need chain rule here. Or more like Kyoko, are you confused when I tell you you need chain rule? Right, you see the layer there. That means you have to see the layer. So, Ainesh, you have to see the layer like this. Both of you did not do this. Both of you did not do my technique, right? If you do my technique, it will be much easier. Start by differentiation W minus 1. Stop being stubborn. This is the third time I tell you already. Stop being stubborn.
What do I do?
Like how I do it, you pretend that the guy inside is a letter, in this case W, because U we already used, so W minus 1. Why are we doing this, Ines? Tell me the reason.
So you can substitute it in later.
No, the reason is, I mean, you're right, you have to resubstitute it back, but that means we are making our life harder, right, by adding more tasks. So what is the benefit of this task? Because W power minus 1 looks basic, and then you can differentiate. Same thing with you lah, Kyoko. You are not applying my technique. Just differentiate the W minus 1 first. Stop being stubborn, you both of you. I know this doesn't make sense. I know it doesn't make sense, but differentiate W minus 1, please. Good. Minus W minus 2. And then how to top it off? Remember how to top it off, Ines? To top it off, you will need, right? That should be fine. Oh, come on, people doing it in front of you. I know it doesn't make sense. To top it off, after you do minus W minus 2, then you need to top it off by, just check the previous page. What did I do? Let's check the previous page. What did I do? How do I apply chain rule? If you cannot even see the application of chain rule, then at least ask me where it is.
It will be like this?
No.
No.
W prime. W prime, that's how you top it up.
Is there no W prime?
How can W prime be 2W? I'm very confused.
No, isn't minus W to the power of minus 2 not W prime?
What is W?
Cosine X.
Yeah, so W prime will be? Minus sine X, right?
Yeah.
To answer your question, so what is minus W minus 2? That would be minus, what's W?
Minus sine X.
What is W? Okay, what is W?
Sorry, cosine.
Keep cosine. X minus 2. So are they the same? They're not. It's confusing, I know. It's really confusing. I know. I ask forgiveness for the topic. It's very confusing. It doesn't make sense. But if you test this in Desmos, you will be correct. I mean, it's a law for a reason. It is a law for a reason. I'm going to erase my working, okay? So that you can redo it, so that your brain rewires itself. The brain must rewire itself for the purpose of differentiation one. So I guess I'm glad we start early. Okay, Kyoko, I top it off by W prime. Did I do that every time in chain rule?
Yeah.
First, I pretend, right? I pretend. Then I differentiate. That's 1, that's 2, and then I top it off with this. Why am I doing this? It doesn't make sense totally. It does not. The only proof I have for you is later when you test in Desmos, you will be correct. Okay? So please do it this way. You have to rewire your brain a little bit. Apologize in advance. So Kyoko, finish up the V prime. What's V prime? U2 NH, what's the V prime? What's negative W minus 2 times W prime? What is that? Right? You have successfully completed this weird thing, right? So good for you. Now, you have to complete the quotient rule. So you already gotten your V prime. If you want to simplify, can. If you want to leave it like that, also can. That's up to you. Now, complete the quotient rule. Kyoko, what's W prime? Very good. So you now have your V prime. Now you know why I asked you to do V prime separately. It's confusing. It's confusing enough as is. For now, it's confusing enough as is. So you do it separately. Now you complete your quotient rule, please. You're lacking your quotient rule a little bit.
Is my algebra just wrong, or is cosine x multiplied by cosine x to the power of -1 just 1?
Oh, it is just one. Oh, it is. It's 1 plus. You're correct. You notice the simplification. It is 1 plus something. It is. You're correct. Now focus on the second thing. The second thing has its own peculiarity, so I hope you can sort it out. Good. Good. Which I will challenge you, this can be simplified further. In fact, it can be simplified until exactly the same as the first answer. Do you remember your first answer? It was secant square x, remember?
Yeah.
This guy can be secant square x. Treat this as a proving question. Simplify further until that, because you're on your right track. Kyoko, what is cosine x times cosine x minus 1? What is it?
1.
Yeah, so that is 1. There's a lot of simplification to be done in Trigo, yeah. So if you notice it, simplify lah. Nothing wrong with that. Finance was sine square over cosine square, basically, right? That's sine square over cosine square, right?
Oh, it's cosine x to the power of -2.
I know. Cosine x to the power of -2 is over cosine square, right?
Maybe
Power -2 means you're below there.
1 by cosine square x.
Yeah, correct. Which means it's sine square x over cosine square x, right?
Yes.
So what is a simplification of sine square x over cosine square x, if there is any? If it could be simplified, it would be nice lah. If cannot, then don't force it.
Sine square x by cosine square.
This is good thing. This is a good training for your trigo. I mean, like, accidentally do that, which is great. This is good.
That's tangent square x.
Yeah, correct. If you like it, you write down 1 plus tangent square x. Kyoko, simplify.
Secant square x.
Correct. Which convince you that this is all correct.
Yeah.
Treat this as a training in Trigo, right? Treat this as a training in Trigo, which is a very good thing. So you're whacking 2 big birds. Okay. So okay, Anisha?
Yeah.
You have one last scenario to consider, which is the sine 2x. Should be the easiest one. The challenge remains the same. You apply 2 rules and they should arrive at the same answer. Let me see your chain rule. Let me see your chain rule properly. The minus can change, Kyoko, if we have plus, right? Quite convenient that way. So Kyoko, can you simplify further? Is it possible to simplify further? If it is possible, let's do it. If it is not, then we shouldn't force it. Is it possible, Kyoko, that 1 plus tangent square x is actually equal to your first answer? What was your first answer? The one that uses quotient rule, right? What was it? Is it possible? The answer was secant square x, right? Is it possible that 1 plus tangent square x is actually secant square x? Kyoko,
Yeah.
how do you know? From the identities, right?
Mm.
At this point, you should be convinced that you're correct, right?
Mm.
Okay, this seems like a lot of work. After a while, this will be like it's a very smooth thing for you. I mean, both of you are just starting, right? But I hope you feel a sense of accomplishment because both answer is the same. There is very unlikely that both are wrong. It's very likely that both are actually correct. Okay, Kyoko?
Mm.
Now scenario 3, please. Hey. So you're setting up the product rule way, is it, Ainesh?
Yeah.
Okay, so that's the first thing, like product rule. A very good setup. I like it. And did you do the product rule correctly? I like that you take away the 2 for a while. I guess I like it. Guess I like it. Guess I don't mind it.
It's not the best of presentations.
For now, yeah, it's not the best. So I'll just pretend that you are simply correct. The presentation is bad, but we have an understanding for now. We just started. Removing the 2 is not a bad idea though. So maybe later on we can present it more. So Kyoko, you are setting up for product rule first, right? That's your idea. So I guess that's a good setup. So apply the product rule and rewrite u prime v plus uv prime. You're going to need it anyway.
I hate you.
Okay, good memorization, Kyoko. So Ainesh, if you want to do chain rule, you have to set it up as chain rule. If it is not set up, then you set it up inside, outside, inside, outside. What's inside, what's outside.
And so the rule is
before the rule, you set it up first, right? Before the rule, you set it up first.
it is set up.
Oh, good. So who's the inside?
2x. So then
So you pretend the inside to be what? That's part of the setup, right? The first step is to pretend that the inside is
W.
something. A W is fine. W is fine. Because then it will look more basic. If it is more basic, then you can start to differentiate. So differentiate and then then you do the chain rule.
Yeah, won't it be 0?
Write down as W, please. Write down as W, not even writing the W. Write down the W.
W.
The inside is W. Write down. Good.
Yeah.
Right. Then dy dx, right? So the dy dx will be the differentiation of sine W, right?
Yeah.
So differentiate sine W. It's not 0. That's wrong. What's the differentiation of sine x?
Differentiation of sine W is cosine W.
Okay, then you write down cosine W. And to cap it off, that's the second step, right? The first step, pretend W. Second, differentiate, become cosine W. The third step is to cap it off with times. Come on.
Times W prime W.
Yeah, times W prime. So we write it down. That's a proper chain rule if I were to see one. Right? So now then you just resubstitute. And hopefully you will get the same answer.
And hold on.
And what's
W prime is 0. So the answer is 0.
W prime is not 0. Hey, come on. That's incorrect.
Why is it not 0?
2x, right? 2x.
Yeah.
Y equals to 2x. What's the differentiation of 2x?
0. Become x to the power of 0. Oh, which is 1. Oh.
Which is 1. Just 1. Yeah, good. Yeah. Good job,
That's a
Poti.
bit.
Good job thinking. So Kyoko, I think you did a slight mistake here. It's not a rule problem. You did the rule correctly, yeah? You did the rule correctly. So you always have problem afterwards. Like it's as if the trigo is confusing you. So pay attention to what's happening here. It's not a rule problem anymore. You have an algebra problem. Write down the W. Yeah, no, you shouldn't leave the W there, Ines. You shouldn't. You shouldn't. You
No,
should
simplify
revert.
it now. Like this.
Right, which should convince you that you are correct.
Yes.
Okay. Now you don't need me to tell you, right? Both product rule and chain rule gives you the same answer.
Yeah, can I go wash up my face, please?
Yes, yes. Kyoko, did you not see your mistake? Kyoko?
No.
All right, so I'm gonna, how do we find our own mistake, right? After I tell you there's a mistake, you cannot find it because it is true that we are blind to our own mistakes. No, that is true. We never intentionally make mistake. We think that what we did is correct. That's just a part of being human. There's nothing special with me seeing your mistake. However, you have to learn how to see your own mistake. The technique is very simple. I just go one by one. So I did tell you that this line is already correct. Okay. Now let's go one by one from this line to the next line. So 2 cosine x times cosine x. Is this correct or not? Okay, so let's say that this is correct, no? Because you investigated the 2. The 2 correct? That's what you're saying, right? The cosine square is also correct. That's what you're saying, right? So now let's investigate the second one. No? So slowly, is the minus correct?
Yes.
You're assuming that therefore this is a 1, so I'm just going to bring the 1 up. Is the 1 correct?
No.
Okay, I'm back.
How did you see? Yes, welcome back. How did you see your own mistake, Kyoko?
Actually, I thought that I was going to include this for everything, but
That doesn't make sense because this is times. You have an algebra problem. You have a big algebra problem. First of all, why is this even a times? It's supposed to be a plus. Right? It's supposed to be a plus. Be careful. I think you have an algebra problem confused by trigo. I think maybe when it's a normal algebra, you could. Let's see. Okay. Good job, Ines. Any questions so far?
No.
We'll wait for a while for Kyoko, and then I'll tell you something else, and our basic discussion is done. Then we can start to do exam questions, I guess. I guess that's an advance. That's
Now?
No, not now.
Okay.
You die, Kyoko will die.
Yeah.
Kyoko, fix it up quickly, please. Right. So we'll simplify further, Kyoko, because we'll come back to this, okay? Go to page 8 first, but you're doing it correctly now. Now, let me summarize what we learned, Ines and Kyoko,
Yeah.
The first thing is I teach you the pattern of this one. Like for example, 2x to the power 4 minus 3x to the power minus half. You know how to differentiate this, and you know how to integrate this. Correct? Kyoko and Ines, correct, yeah? Page 8, yeah? This is basic, no? This is basic for polynomial. The basic for trigo is if you have sine x, the differentiation will be cosine x minus sine x minus cosine x and then sine x, and then it will repeat, correct? That's the basic for trigo. This one. And then the basic for in this there's only one, e to the power of x becomes e to the power of x, and then it repeats forever. right? The simplest to memorize, even though it doesn't make sense. These are your basics. This works for integration and differentiation. Am I correct or not, Ainesh? Once you learn these three patterns, you can do both and basic stuff, correct?
Yeah.
Now, today, you make very clear three rules. The product rule, the PR, the quotient rule, and then the chain rule. It totally doesn't make a lot of sense. It's just formula and whatever. But with the power of Desmos, you at least know that it is correct, right? Now, what did I tell you in the start of learning product rule, quotient rule, and chain rule? I tell you that this only applies to differentiation, right? That means you will need your rules when things are not basic rule. So you basically identify sine x cubed. Is this basic or not, Yoko? Is this basic or not? That means, do you need the rule or do you not need the rule? That's the main question here. Do you need rule or not?
Yeah.
Okay. Ainesh, which rule do you think is best?
The C rule. What's
The
that?
chain rule. The chain rule. Why, in your own words?
Because there's an inside and an outside.
Very good. I understand what you're saying. Kyoko, do you have any other opinion? Which rule to use?
Product rule.
Product rule. How would you set this up as product rule? Because in the case of chain rule, you say inside, outside, so that one makes sense. Can you set this up as product? Something times something. Is it possible? Sine x times sine x times 2 sine square x. Okay, then my question is you must be very careful. Okay. Is this cube belonging to x or to the sine x? Which one is it?
X.
So can you set it up this way? No. Then be very careful. No, this is also a wrong setup. Yeah? You cannot do this also. Do you understand? Do you understand that you cannot do this? Because this is not equal to that, right? Understand, yeah? So unless we can set it up as product rule, we cannot use product rule, just chain rule. So don't mistake me. I don't mean that in every scenario there are two options. That's not always the case. Sometimes there's only one option. And I think that's fine. That's okay. Okay. Any questions so far? Kyoko and Ainesh. Now, to close this off, is there any rule for integration? What are the rules for integration? What happens if they give you sine x times cosine x, and then you have to integrate this? Integrate sine x times cosine x. If you differentiate, no problem. If you integrate, is there any rule for this or not? Do we just follow the normal product rule? What do you think? What are your guesses, Kyoko and Ainesh? It's a guess, yeah, I understand. I understand that you have no understanding and background, but I still need you to guess a little. How shall we integrate sine x times cosine x?
Negative cosine x times sine x.
Negative cosine x times negative sine x?
Sine x.
Times sine x. So that means what you're proposing is, Kyoko, you will integrate this separately and then times integrate this separately, correct? Now, how do we know whether our guess is correct or not? I mean, we are grappling in the dark here. How can we tell? Ainesh and
Why would we use the product rule?
All right, then Ainesh has another opinion. Why don't we use the product? So here's one option, this option. So Ainesh, how could we use the product rule to integrate this then?
The uv prime times u for prime v.
u prime v plus uv prime. Okay. However, please remember that that was originally used for differentiation. Can we just use it for integration? What do you think? What's your guess here?
Yeah, please. Hopefully.
Right. Right. So if I follow you, then what happens? Ainesh and Kyoko, the result will be u prime v. What's u prime? U prime is a cosine x, right? Cosine x times cosine x, right?
Actually, no, that doesn't make any sense.
Yeah, because that is the result of the differentiation.
Yeah, that doesn't make sense.
So I am just differentiating here. I am not integrating here.
Yeah.
So we cannot just use product rule like that. We cannot, because it turns out product rule is only for differentiation. But the temptation is great, Ainesh and Kyoko. Let me state this carefully. The temptation is great when they ask you to integrate this to simply use product rule. Why? Because your school will teach you product rule 1 month before they ask you to integrate. By then, your brain is hardwired for product rule. Whenever you see times, you want a product rule. Even though it's integration, that habit is extremely hard to break in the first week. Right now, I'm teaching you side by side so that I can say one thing. You cannot use product rule to integrate. It seems very obvious, but Ainesh, you were tempted, right, to try, correct or not?
Yeah.
And then after you do it, and then you realize, oh, wait a minute, that does not make sense. That means your brain is thinking, you're switching between, oh, wait, is this correct or not? After you do product rule for 1 month, and then you integrate, then you don't even realize that you'll be tempted to use product rule in a wrong situation. You don't even think this is right or wrong. Just now, you try to apply it, and then you realize it doesn't make sense. It's a sign that your brain can. So I'm just preventing bad habits from happening. Because I acknowledge in the end, these are memorization. It's very hard to tell our brain to stop memorizing stuff. Kyoko and Ainesh, do you understand? We cannot apply product rule here.
Yeah.
And so, a simple homework in terms of math, we have no other option, right? This is the proposal made by Kyoko. This is the result of the integration of sine x and cosine x. If you have no other option, then the only thing to do is to try this on Desmos. Okay, that will be your homework. Do you understand your homework, Ainesh and Kyoko?
Yeah.
Confirm your integration on Desmos, please. Okay. Right.
Confirm this one.
Yeah. Confirm that is this the integration for this in Desmos? Do you know how to do it? That's my question, right? Okay. You have to do some thinking there. Okay, good job arriving this far. I mean, we are not very far on the topic, but you have covered all the basics. So I feel slightly assured. I'm not happy with the speed, but I'm happy with the achievement. So bad. Any other question for today?
No.
All right, thank you. I'll see you on Sunday. And Ainesh, hopefully I will see you on Sunday. Okay?
Yeah.
All right. Take care, everybody. Have a good weekend.
Bye.